Here's a problem that's basically the reverse of the last one we worked. In this case, you're given the pH and you want to figure out hydronium. Definition of pH is the negative log of hydronium concentration. This time we know the pH is 5.12. So we have to do two things to get the hydronium. First, the negative sign has to come over to the left. So we have negative 5.12 equals the log of hydronium. And then to get rid of the log term, you have to do the opposite of log, or the anti-log. That's using 10 as the base and raising both sides using 10 as the base. 10 raised to the log, those two functions cancel each other out. So the right-hand side is just the concentration of hydronium. The left-hand side is 10 raised to the negative 5.12. And again, you should have a button on your calculator, 10 to the x, and so if you put in negative 5.12 and then hit the 10 to the x, or some calculators you have to hit the 10 to the x button first and then the negative 5.12, either way you'll get 7.59 times 10 to the negative 6 if you plug that into your calculator correctly. And these square brackets always have the same unit, which is molarity. There's another function, it's very similar to pH, it's the pOH. pOH just stands for the negative log of OH, or hydroxide concentration. It's useful because if you know the pH, you automatically can calculate the pOH, because pH plus pOH always adds up to 14. So here's a solution that has a pH of 1.18. We want to figure out all of these quantities. The easiest one to get right away is pOH, because pH plus pOH adds up to 14. 1.18 is the pH. pOH is unknown. We can calculate the pOH by subtracting 14 minus 1.18. That'll be 12.82. To calculate hydronium and hydroxide, we can use the definitions. pH is the negative log of hydronium. If the pH is 1.18, and that equals negative log of hydronium, same two steps to get hydronium by itself. Bring the negative sign over, and then use 10 as the base to cancel out the log term. 10 to the negative 1.18 power should be 6.61 times 10 to the negative 2. That's the concentration of hydronium. We can calculate the pOH to give us the hydroxide concentration, same way. pOH was 12.82. Bring the negative sign over. Negative 12.82 equals the log of hydroxide. Get rid of the log by using 10 as the base. 10 to the negative 12.82 is 1.51 times 10 to the negative 13. That's the concentration of hydroxide. Is this solution acidic, basic, or neutral? You can tell that just by looking at the pH. pH is less than 7. That tells you this is an acidic solution. Or if you look at hydronium and compare it to hydroxide, hydronium is greater than hydroxide. So that's the other way you can tell it must be an acidic solution.